right, I think we got it started. Yep, we got the green light. Let's go. Okay, so trig functions, any angle. Some of this might be like easy for you because we kind of hit on those topics already, not formally. So I don't see you guys really struggling with this, any part of this. But if there are questions, please ask them. Okay. So we're going to be using the definitions of trig functions. You should already have them. We're going to use the signs of the trig functions. We're going to talk about those, find reference angles, and then use those reference angles. Simple as that. I can change the slide, I mean. Change the sign. So, sine, cosine, tangent. You guys remember how I said they were opposite over adjacent? This is a kind of different take on it. They're calling y, x, and r. But it makes sense. If my angle theta is here, let me use some red. If this is my angle theta, what side is opposite? The y is, right? And the adjacent is x. And the hypotenuse, of course, is the radius of my unit circle. So instead of doing opposite, adjacent, hypotenuse, they're just using the letter references, but it's still the same thing. Okay? So don't confuse. Don't think it's something different. It's new definitions. They're the same definitions. No, the hypotenuse will never be negative because the hypotenuse is a distance. It's how far away you are from 0. Okay? As opposed to, I believe, is it physics or chem where they do vectors?
Wait,
and
where
then
they
you have
do what?
Where they do vectors.
I haven't got that.
And then they do have like the opposite, like what cancels it out.
Yeah.
Kind of thing, but that would be a negative type. But it's not the hypotenuse. Same kind of similar idea. Not a unit circle size though. All right, I can change it.
Hold on, stop and check first. Yeah.
Thanks for closing your laptop. Do I want to comment on what? Almond? Thank you. Oh, I'm good. And I can't eat when I'm talking because then I start spraying everywhere. Oh, see it?
Eat it before you talk.
Oh! Ah! I'm going to call him Al.
Ow.
I also have an orange, see? And the almond is not?
Wait, that's dried out.
That's dried out.
Where's your potatoes?
No, that's disgusting. Okay. Thank you. So, let's do it. You guys ready?
Yeah.
No, I don't have a potato.
like
I love potatoes.
You don't have a dried up potato in that casserole.
Maybe. So here we go. Thank you very much, Joe. I definitely need a new marker here. So they want me to find, so they're saying let P equal 1 comma negative 3, be a point on the terminal side of theta, and they want me to find all the other trig functions, okay? So I'm going to first have to set that up. Where is 1 comma negative 3? It's going to be end up in quadrant 4, right? Because I got 1, 1, 2, 3, correct?
Yeah.
There's the terminal, there's a point on the terminal end of this. Okay? So, let me get rid of that. What do I need to do to create my triangle? Come back to the x, right? So I'm going to come back up, 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 up. There it is. That means that this is 1 and this is negative 3. Okay? I can use Pythagoras theorem to find the hypotenuse, correct? That would be 1 squared plus negative 3 squared equals c squared. 1 plus 9 is equal to c squared. So c is going to be the square root of 10, correct?
Yeah.
All right, so I've got all 3 there. I'm going to use red. Square root of 10. So now I can start writing my trig functions. Okay? So I don't know what theta is, just an FYI. This is theta, right? Because I had to rotate that many to get to that point. It's always going to be the big one, the one on the outside. Because you always start at 0, right? And then you rotate around to get to there.
Yeah.
Oh, because it's negative.
In this, well, if I went the other way, it would be a negative angle. Okay, so we're kind of jumping ahead on the lesson, but that's okay because the question came up. Why wouldn't you make it the tiny one? The one that's in here. And technically that's what we're using. What we're using is going to be that tiny angle, but that is called a reference angle. It's a coterminal angle along with that should have an equivalent sine, cosine, tangent, secant, cosecant, cotangent. Okay? But when they ask you for theta, you should always start at 0 and rotate this way, correct? So in this case, theta would truly be what, greater than 270? We'll say maybe 300. It's not true, but it would be some angle. But we will always use the reference angle to find what we need to find. In this case, not a big deal because who cares what theta is, right? They don't ask us for that. But I'll go ahead and start writing all my trig functions. Sine theta, sine is the opposite, which is going to be -3 over the hypotenuse. Don't worry about rationalizing it. Don't worry about rationalizing that.
Yeah, you do. Yeah, sometimes they
They do, but right now I'm not going to worry about rationalizing it. I want to get to my lecture. All right? So yeah, if they ask you to, do it over there, but not right now. I'm not going to worry about it. What's cosine going to be? I'll go over here. Cosine theta is adjacent,
Yeah.
right?
Yeah.
So it's going to be 1 over radical 10.
Yep.
Tangent theta. Tangent theta will be opposite over
adjacent.
adjacent. So I want -3 over 1, which is just -3. Everyone okay? Anybody got questions? Ernie, we good? Atrás? Okay. Let's do cosecant. It's going to be radical 10
Yeah.
over -3. Oops, I forgot my theta, but you get the point, right?
Yeah.
My secant theta will be the reciprocal of cosine theta.
Yeah.
So it's just going to be radical 10. I know what you meant. And then cotangent on theta will be a -1/3. Correct. Not so bad?
Pretty easy.
Cool, cool, cool.
Don't.
I'm not. I'm here. I am here.
That reminds me of that movie that we were with the Dr. Seuss.
Mama, Mitchell. Hey, are they going to mark you guys in?
They'll probably end up fixing their
Present?
brief.
Yeah, I saw that. So. I think I'll just fix it up.
What classes? You didn't go to all 56 there.
Man, I tell you, I get confused with the 2 classes. No, like, because what was it, yesterday or a couple days ago? I gave you guys homework for 8.3 instead of 4.3. You guys, some people didn't see it because I deleted it. But they're like, oh, that's not from this class. You guys are all right, everyone okay on how that's going to work for the when they ask you to find, when they give you a point? One's x, one's y, find the hypotenuse, spit out all the different trig functions, right? Now, this is where it gets good. Remember I told you that we're going to have the quadrant. You guys remember the quadrantal angles?
Yeah.
And how they're unique, okay? In this case, they want us to find cosine and cosecant. I'm going to just teach you all of them, okay? Because it's going to be easier. You're going to want to know what they are. And some of them, you'll learn to recognize them. If I'm at 0 degrees, I'm here, correct?
Yeah.
What are the coordinates to that?
0, 0. Oh, 0, 1. Sorry.
0, 0.
It's 0, 1.
1,
It's
0.
1, 0.
1, 0.
Oops.
Yeah.
Okay, so if you remember what I told you, yeah, go for it. This is x, this is y, right? Now, what's the radius? 1. So I have those, and I know my radius is 1. So I need those because technically I've got x, y, and then I've got hypotenuse, right?
Yeah.
Technically. Yeah. So let's go ahead and start with this. They want cosine, so I'll start with cosine at 0 degrees. So what's the x value?
1.
I'm done. What is the sine value?
0.
Boom. Okay? That means that the secant is how much?
Zero.
No.
What?
One.
How do you flip 1? You flip 1, you get 1, right? What is the cosecant going to be? Yeah, this one it's a little different because if I flip 0, technically it's 0 over 1, right? And if I flip that, where's the 0 end up at? So I'm going to say undefined. Be careful there with that thought process there. All right, now here's where it gets kind of weird. Tangent. Tangent theta. Tangent is sine over cosine, correct? So that means I'm going to take 0 over 1. What is 0 over 1? Okay. And then cotangent would be 1 over 0, wouldn't it? Therefore, undefined. Make sense?
Yeah.
That's for the degree.
That's for your quadrantals. Yeah. This one's at 0 degrees.
So is that how you find your theta?
No, we still don't know what theta. Well, technically theta is 0. The angle measurement there, 0 degrees. There's a question you want to ask. It's in there. I can see it in your face.
Yeah, I feel like you're gonna go over.
No, I'm done.
This is the whole lesson?
No, this is the whole thing here.
Oh yeah.
All right, so maybe if we don't cover it, then make sure you ask that question, okay? So with this, oh, you're looking at me. I thought you were talking to me. Can I change the slide? You guys need a minute. Okay. For everyone else waiting, I want you to find the 6 trig functions for 90 degrees, for pi halves. For pi halves.
You got it.
You got short order?
What is that?
Don't tell him what it is.
That reminds me.
Shits?
Were you the one?
Bullshit.
You know how to sign Coca-Cola?
That shooting lines, dog.
That's exactly what it is. Because
Shooting lines.
Coca-Cola used to have cocaine in it.
I know. I use that right.
How crazy, huh? Talk about making a loyal following.
That's lit.
All right, I'm gonna change the slide.
I wanted to go from back in the day.
Find me those 6 for 90 degrees, please.
The sign is the X. Cosine is Y. Oh, wait. Cosine is you just didn't want to
Was there school Monday?
No. Yeah. No, there
This
isn't.
Monday. This week.
Yeah. Oh, yeah. There was school this past Monday.
You weren't here.
Oh, but I was gone, huh? 'Cause
Oh yeah, that one.
I was looking for my other tutoring slip. Because I tutored Monday, Tuesday. But I was gone Monday. Hold on. Man, this month is going by fast, huh? Guess what? This semester's going to... Did I tell you guys that? This semester is going to go... How many people think that quarter 2 was fast last semester?
What? Put your hands down.
Semester 2 will go by just as fast as quarter 2. It's going to feel like it's...
Because I don't want semester 2 to be like.
School will be over tomorrow.
Huh? Right, well, it's, look. It's the end of January.
Okay, really not. Don't remind me.
February's already a short month as it is. Then we'll have March. You'll have spring break in there. And then when you come back, it'll be testing season. Which means we're pretty much done.
Don't say that.
When is our next break?
Monday?
Wait, we haven't created a week.
Okay, let's do this one real quick. Here's my point. This is 1, 0, right? So sine will be, oh sorry, that should be sine pi halves. What's my sine at pi halves? 0? 1. Cosine? Cosecant. What?
Your coordinate for
It's wrong, huh? It's 0, 1.
Yeah, 0, 1.
I was looking at it. I'm like, it looks like just like the one I did last. But thank you. So sine should be 1. Those are correct. The coordinate's not. What's my cosecant?
1. I went to Katie. I was like,
underfoot.
Because it's 1 over 1.
Yeah.
What's my
Secant.
secant? This one is going to be, I was going to do this. Is that cool with you guys?
Yeah.
Yeah.
Empty set? Okay.
Wait, I have a question.
But it's not the empty set. It's undefined. It's not the empty set. It's undefined. What's up? Go ahead.
Sine of theta is 1.
Yeah.
Opposite.
Not sine of, well, we know theta. It's sine of pi halves. So sine of 90 in this case,
Oh.
we know theta. Theta's up top. Correct?
Okay, yeah, I just don't.
What is tan pi halves here? Oh, that's a
that's undefined.
tangent. Tangent is sine over cosine. So 1 over 0 is undefined. And therefore cotangent.
0.
Cool. You guys get that?
Yeah.
All right, so I don't need to do the other two, right?
No.
But it would be the same idea for the 180 degrees and the same thing for 270 degrees. So I'm going to move on.
Oh.
What?
I just got why you're getting because I understand how you're getting the coordinates, but I just figured it out.
How?
Because it's like you have 0, and then you have 90, then you have 180. Yeah.
Okay, so remember the unit circle?
Yeah.
So I've got a circle whose radius is 1. So that means I've moved 1 unit this way, putting me at 1 comma 0.
Yeah.
And if I go straight up, I know that this radius is 1, correct? So that means I should go 0 on x and 1 up.
Yeah.
Cool. Just verifying. All right, moving on. Let's talk about the signs on those, okay? All your functions are going to be positive in quadrant 1. Because sine is positive, cosine is positive. Does that make sense? That means that tangent should also be positive. Because positive over positive is a
Positive.
Make sense? So here, sine, positive, right? I go up, cosine, positive, tangent, positive. And if I flip positives, they should still be,
Positive.
so all the cofunctions will also be. Now here, which of the two is negative?
No.
Negative. What?
Is sine positive or negative?
Positive.
It's positive, and cosine,
Cosecant.
cosine is
Negative.
negative. Therefore, think about those. That means that my tangent would end up being a negative value, because it would be the opposite over, it would be sine over cosine, so positive over negative makes negative. And then think about how that affects your cofunctions as well, okay? Over in quadrant 3, what's sine? Is sine positive or negative?
Negative.
Cosine is?
Negative.
Tangent is positive. Because negative over negative makes a positive. So be careful there. And then finally we've got quadrant 3. Sine is negative.
4.
Cosine is
Sorry, stupid.
tangent would be
Negative.
negative. Because a negative over positive makes negative.
Are these blue diamonds?
Sine over cosine, right? Is tangent. Cool?
No.
Not cool?
I just need to.
Critique it. Let me critique your work. I love it.
Sine is y.
Let me take it all in.
So like in the first one, x and y are both positive.
Oh, wait, that's the,
You're reading the inside parts,
Yeah.
and they scare me.
They're confusing.
Yes, that's why I wrote stuff on the side. That makes more sense.
Okay, so write the stuff on the side.
Yeah, because from there, I know that you can interpret that to all the other cofunctions.
So if sine is positive, then it's I don't know, but it would be positive.
Well, think about it. Sine is y, right? In order to be here, I got to go up, which means that the y is positive, correct? So sine is positive. On x, I got to go this way, don't I? Which means x is positive as well. That's why cosine is positive. Now tangent is sine over cosine, correct? So what's a positive divided by a positive? Boom. What would tangent be here?
Negative.
Tangent would be negative here. And you'll learn to see those patterns. There's always two where they're both positive, and two where they're both negatives. And usually the tangents are going to be vertical on the vertical sides. No, I wish.
It can be.
But no, I kind of wish, but I don't, because then that would make this class really, really short.
I'd be okay with
I'd be okay with that.
I'll be okay with a 30-minute class.
That means you'd be doing like 2-3 lessons super fast and.
That's
that.
okay with
We
me.
gotta do sometimes.
Yes, we do sometimes.
It's like great, man.
I'm gonna move on.
No.
Not with trig. Love me some trig.
No.
Gotta take it slow.
Draw like Mr. Munoz. Say something, anything. Like an object.
Like an object? Slide rule? That's like, yeah, that's what I thought.
Say orange.
Okay, now what?
Anything. No, not that word. That's weird.
You said an object.
Oh, you say anything but that.
Taurus.
A tortoise?
Taurus.
Taurus?
Taurus. Not a Ford Taurus.
Like that sign?
Like the zodiac.
No.
Okay, give me an animal.
I'm a Taurus.
Give you an animal?
Give me an animal.
Donkey.
Donkey.
It's not our
Donkey. Donkey.
Donkey? Okay. Go out on your lesson.
Okay.
Is she gonna draw the donkey?
Okay. Check it out. They are asking us where
No.
theta is.
No. C. C.
They're asking us where theta is. And they're giving us some conditions. Okay? They're telling me that the sine of theta is less than 0. If the sine of theta is less than 0, am I positive or am I negative? So where's the sine negative? Down, right? So that means that that angle is either here
Or there.
or it's going to be over here, correct?
Correct.
Now the other condition says cosine is less than 0.
So it's
That's it's quadrant third.
quadrant.
Is it this one?
No. That's 4. That one.
So that means that this theta is in quadrant 3.
Nice.
Cool?
Yeah.
Yeah. Don't
So here's what they'll do. Go ahead. Go ahead and talk about that real quick. You guys are having a good conversation.
So, look at when your sine is, and which one of the quadrants appears as sine less than?
Definitely. Definitely. Yeah. Definitely. Yeah.
So cosine is also less than
Exclude all
0.
that.
There's only going to be one quadrant where cosine is less than 0.
Definitely. Yeah.
Since you can consider
Definitely. Yeah.
Stress or depressed? Yeah. If you have a little less depressed, then yeah.
Huh?
Finally talk.
If cosine is
Have a very
negative.
healthy conversation.
Yeah, just be careful with the ones that have.
It was actually, it wasn't that bad. It was actually a really good conversation.
Because all you're really doing is really signs.
Actually,
So if you have a positive, it's still positive, right? And if you have a negative, still negative. Now if you have a positive negative, it's negative, correct? If I flip it and I got negative positive, it's still negative. Yeah?
I'm going to
Thank you.
Yeah, we were this morning.
I should do the elementary stuff I used to do, huh?
Shit.
1, 2, 3, all eyes on me.
That's so cute. I'd love to read.
1, 2, all eyes on you is what you should repeat.
Yeah.
That's fun stuff. They do all kinds
Okay,
of.
I haven't been
Okay.
to elementary school for years.
Stop making me
Real life.
Given that tangent of theta is a negative 1/3, and the cosine of theta is less than 0, they want us to find the sine and the secant.
Okay.
So sign has to be positive.
Well,
Okay.
and negative.
Does it?
Yeah, the cosine is negative.
Oh, because you looked at the condition. So, so here's what we're saying. If I looked at tangent, and I know that tangent theta is negative 1/3,
First of all, it's quad 2.
what?
Well, it's going to be in quadrant 2. Thank you.
It could be in quadrant 2,
Or in quadrant 4.
but it could be in quadrant 4.
But cosine is less than 0.
So-
I'm going too fast.
Yeah. So because tangent is negative in quadrant 2
Two.
and in quadrant 4.
Yeah, but the
It
cosine
cannot
is
be
negative.
both of those.
Nope.
Go ahead, say it out loud. Nice and loud so we can hear you.
Quadrant 2.
It has to be the one in quadrant 2 because
Because cosine is
the
negative.
cosine is negative. It's less than 0. So it's not this
Yeah.
one.
Come on.
Okay? So now,
Oh, yeah.
here is angle theta.
Yeah.
Okay?
Yeah.
Well, technically, this is angle theta, but
Same.
you know what I meant.
Is it really just the same thing?
Similar.
It is going to be
Anything closer to
sine cosine tangent of this theta will be equivalent to sine cosine tangent of that theta. Let me talk about it a little bit because it's obviously confusing some people. Okay. There you are. Okay. When I draw an angle, where should I start? I should start at 0, correct? So I could go here and I can stop, right? I could go here and I could stop. I can go here and I could stop. You get the point? But I always have to start at 0. Now, here, go see if it's there. Here I have some terminal side of an angle. What does that mean? That means after whatever amount of degrees I had to rotate, that's where I stop. Okay? So I'm, hey, where'd my stuff go? Someone took my spear. I had a pointer. I guess I'm gonna have to use my Jedi Knight.
No, isn't the black one you're talking about?
I saw it.
I think he just wanted to use it.
It looks like
It's not the shape, it's how you use it. But anyways, so you start at 0, right?
Yeah.
So you could rotate, and then it stops at some point, right? That's all I mean. It stops. That's the terminal side. Stops. That's your terminal side. Wherever it stops is a terminal side. Okay. So the question is, if I have to start at 0, that could be theta, right?
Yeah.
That could be some angle. I don't know what it is. Okay. But how do I know it wasn't this? That would give me the same terminal point, wouldn't it?
Yeah.
How do I know it wasn't a negative angle? Regardless of which one of those 3 it is, they would all stop here, correct?
Yeah.
Would the distance from here to there be different for any one of them?
No.
From this point down to 0. So if I said, oh, 1, 2, 3, 4, 5. So this is 5 units up, right? Would this distance be any different for the red one than from the green one than to the blue one? No, they wouldn't be any different, would they? Because they're all coterminal. They all stop at the same point. So that means that it doesn't matter what side, like let's say this was, I don't know, 3, okay? And I wanted to find the sign of the red one, I would be using this little piece right here, right? It would be 5 over 3. If I did the green one, it would still be 5 over 3. If I did the blue one in reverse, it would still be 5 over 3. So it really doesn't matter where I stop. I'm using what's called the reference angle. For none of those did I ever really use the blue part, did I? I always went in here, and I used.
So when you're finding theta, to figure out where the theta is, it's always the one where the origin is, before you start at 0. Because like that's like my main question is like, how do you know where your theta
Okay.
is? It's on top, it's on the bottom, is it on the farthest side?
Start at 0,
So it's 0.
and then rotate around until you get to that point. So let me give you an example of what I mean. Thank you. So we're kind of jumping around, and that's okay because that's obviously bugging you. Let's say I ended up with an angle here, and this is for some reason, I don't know, 32 degrees. Okay? That's not theta. That is the reference angle that I'm using. Because where should I have started?
0.
I should have started at 0 and gone all the way around to here, correct?
Yeah.
So technically, theta is 180 plus 32. So technically, theta is 212 degrees.
Okay.
That make more sense?
Yeah, it does.
Cool. I don't really care about the 180 up there, because all I need is this 32, because now I have a right angle and I can do trig. But theta is technically 212. Okay? Did that help? String battered. All right.
You got another question behind you.
Oh,
I want to point out that 32 degrees is the freezing point of water and 212 is the boiling point of water.
that's why I picked it. No, I didn't. Thank you, though. All right, so let's get back to this guy, okay? Where did we say he was?
Sorry.
We said he was in here, right?
Yeah.
Okay. Tangent is opposite.
Opposite, which is
So this should be
1.
the negative 1.
No, that's
Opposite over adjacent, right?
Yeah, but
So the opposite should be the negative 1.
But shouldn't it be positive?
No, it's positive.
Yeah, it's positive because.
So then this should be a
Positive.
positive 1, right?
Yeah.
And this should be the...
Negative 3. I was right. Let's go. I did
Okay.
it before you actually did it.
So that's very important. Because if you went the other way, you fools, you're wrong. You just lost points. What's my hypotenuse?
We don't know.
It's going to be
It's gonna be the
1 squared plus 9 squared is 10 is a radical 10.
Yeah.
So this is radical 10. But now I can find you sine and I can find you secant. Sine here would be 1 over radical 10. A theta would be 1 over radical 10, whatever that is. And secant would be radical 10 over negative 3.
Yeah.
Okay? So be careful with those. Any questions on this? Go ahead.
Oh, okay. Yeah. Well, I was like, wait, when is the X? And then I was
Whoa.
like, wait, no, I forgot.
Did you remember that we had another one here? Because that matters. It matters. Because tangent's negative here as well, right? This condition right here told me that it couldn't be this one. Correct? I do, because that tells me the opposite side's length and the the adjacent side's length. Because remember, it's the ratio of opposite over adjacent, correct? So it does matter. Okay? We're good? Moving on. Okay, so I think I kind of did that right now with all my different circles. Reference angles. Reference angles. Reference angles is going to be the small angle that I'm looking for, that I'm actually using to talk about theta in its entirety. Okay? So, here's what and you guys want a picture of this or something?
No.
I'd rather have
Like I said, take a picture, because I'm going to talk about it a little bit more with some pictures.
I prefer
Okay.
different pictures, but okay, I'll take a picture then. My snap is pretty big.
Let me get a pic.
I told someone to do that. Because you told me how to BMX bike. I hadn't seen a BMX, like a true BMX in a long time. Because, like, people go to Walmart and buy it, and they say, oh, I got a BMX. And it's not. It's more like a Triumph or something. So he's like, take a picture. That's going to work, right? Zoom, zoom.
Oh, we just zoom in?
All right, so I'm going to add a slide here. Am I good?
Yeah.
Okay, so I think you probably saw it and it makes sense to you. I can have, let's say I had some angle theta that kind of did this bit, okay? So, oops, I missed that, totally missed that. So technically that would be theta, correct?
Yeah.
But when I do my trig, I'm really not going to use theta. I'm going to use the reference angle that's in here. Oh, sorry. And they'll call it theta prime. Baby theta. Theta prime, okay? Does that make sense?
Yeah.
Do I need to say more about that?
No.
So, even though, so let's say theta turned out to be, I don't know, 110 degrees. What would the reference angle be on that? It would be 70, right? I'd be using 70 as a reference. It's a little, it's like a tick mark. Theta prime.
Baby theta.
Optimus Prime. What? Yeah, if theta was 110 degrees, then my reference angle would be 70 degrees.
Give me theta. Give me theta.
If, give me something greater than 180.
270.
270. No.
Okay, 210.
Okay. So let's say theta was 210. Okay? That would put me in here somewhere. Correct? Theta is 210. What is theta prime in this case? What is it?
60.
30?
60.
60?
Oh, wait, no.
No, the other one is 60. No.
Yeah, because it's 30. Because
So I would be
trying to
using
find the 270.
30 degrees as a reference angle. And I would be finding the sine cosine tangent of 30 degrees and not 210 degrees. Yeah, this would be 60 out here, but I don't want that. Okay, all I want is the reference angle. Does that make sense? Okay. Okay, moving on. Oh, that's not what I wanted to do. Okay, find me the reference angles for these, please. Find me theta prime for all of them.
So, find theta prime and just subtract that.
It just happens we already did the first one.
Yeah.
It just so happens we already did the first one.
Because, why are you doing 180?
If I did, let's graph 210, right? It's here. And I would do that. If I did 360 minus 210, I would get 150 degrees.
That's what this is. That's what the rest of it is.
But that is
From
this angle. Am I really doing that? No, it's not what I want. Technically, you're telling me that the reference angle I'm using is really here,
yeah.
and it's not.
Can you erase that line? So, draw your angle again like how you did.
So here is my 210 degrees.
Yeah, okay. So no. Erase that.
Erase what?
Erase that line.
This?
So if you were to, now can you draw a line from that endpoint to over there? So yeah, like that. So would that be, then would you do the 360 over?
It'll never look like that.
Why?
That's not a right triangle.
Oh, so it has to be a right triangle?
They will, yes. They will always, you will always come back to 0. So let's say, if I ended here, I would come down. If I ended here, I would come down. If I ended here, I'd come up. If I ended here, I would come up. That's what they should all look like, some form of that. Okay? Cool. We already said this one was 30, right? Am I going to try? I'm going to try. I'm going to try to do them with you. Okay, so the fact that there's a 4 denominator, I know I'm working with 45 degrees, right?
Yeah.
So I should have this business going on,
Yeah.
and I got 7. So 1, 2, 3, 4, 5,
You know
6,
why we just didn't go
7,
we already know
right?
315.
That means that my reference angle is 45 degrees.
Yeah.
Or I could say, pi fourths. So it's either one of those,
Yeah.
right?
I had to figure out what the angle was.
Because remember, I have to come back up, Queenie. I gotta come back up.
Yeah. I had to figure out what the actual angle was.
Another one?
No, well, then at that point you're already at 316. Since you're in this quadrant, you're going negative, right? You're going down.
Instead of joy.
Your angle is going down. So you have to go back up to x. So you're trying to find your reference angle. You're trying to find the angle that's inside the triangle.
Can you?
So depending on where you're at, where you're
You guys okay with B?
Yeah.
Anybody got questions on B?
No.
All right, let's
Oh,
do
no,
C.
I got 45. I
Do
just
we-
had to figure out
Ah!
what it was.
I stared into infinity.
7 pi was 15.
All right, negative 240. I go backwards in this case, so that's 90, 180, and here somewhere, right? Correct?
Yeah.
So,
It gives you data.
I know that this is the whole thing is 240. I'm gonna take away 180 for the bottom part.
Subtract this.
What's that leave me with?
You would just subtract 315 from.
Well, it's still a distance, right?
Minus 315, and then get 45.
So no, but I'm gonna treat it as a positive because all I want is the difference between the whole red thing and I want to take that piece away. So that would leave me with 60 degrees.
Yeah, but.
Well, when I draw it, it does.
Yeah, but
After that, not really.
Then.
You'll want a positive. You'll want a positive reference angle. What's up?
Wouldn't you subtract it by 180 again?
No,
Why don't you do it twice?
not really.
Isn't this part your reference angle?
You found a.
No, that would be a different theta. The one I'm actually using is going to be in here. I'm always going to be after the one that's inside of the little triangle, the little corner one. That's 0.
your blue one is writing in green.
So when I did, so let me do that again. You were okay here, correct? My reference angle. Okay, that's what makes sense to me. Thank you. Everyone's okay that this is 240 degrees, negative 240 degrees?
Yeah.
That red arc? That is theta, okay? That is theta. The one that I'm going to trig with is this angle that goes from here to there. So my question to you is, how many degrees is that little angle?
60.
However you do that, mathematically, is up to you.
So is that?
It's a 60. My theta prime is 60 degrees. Okay? My theta should always be, my theta prime should always be a positive. What I trig with needs to be a positive angle. Okay? We're okay? Go ahead. I know, you're asking me exactly what he just said. Wouldn't this be theta prime? Oh. Then what? Show me.
And I know. Oh, that's right.
No. You always come back to this. And that's okay. There's nothing wrong with that. You mean 240, but yeah.
No, it's a negative.
So, thank you.
Doesn't matter.
Thank you.
240 minus 180.
Come on, I want to get done. I don't want a small lesson. But you're not the first one to say it, so I'm going to say it anyway, okay? Your reference triangles. Your reference triangles will always look something like this. If they're in positive, in quadrant 1, they'll look like that. They might be skinnier, longer, but they'll always have this shape there. In quadrant 2, they'll do this. In quadrant 3, they'll do this. See how I always come back to X? So that's what they should all look like. There's a picture, a mental image of all of them.
So it never goes.
Never, never, ever, ever come back to Y. Ever, ever, ever. Don't do that. Not nice. Okay. You would probably end up. Well, you could get the X's and the Y's, but it's just habit. Because technically, here's what's gonna happen. So let me show you an image, okay? And I want to do. I'm trying to think of. Okay, cool. So here's what I want to do. Thank you. Thank you. Thank you. let's do, as an example, 30 degrees, okay?
Yeah.
Okay, so I'm going to make an angle, and it's 30 degrees, okay? Right there?
Yeah.
And if I did, let's see here, for now, I know that this is going to be 1, 2, radical 3, correct?
Yeah.
And if I talk about the sine of 30 degrees, I would get 1/2, right? Now let's say that I ended up doing my 30 and then I went this way. What is this angle measurement here now?
Yeah,
60, isn't it?
Yeah.
Okay. Am I still working with sine 30?
No.
No, not anymore, right? What would I be working with?
Sine 60.
It's a different angle. So if I ever do something that's greater than that and I come back to the y-axis, I'm no longer using
The same angle.
the angle that I want. I'm using the complement of it, and that's not what I'm after. Okay.
I got another question over there.
Okay.
So like, you could find the sine. So like, you could find the sine of 30 by like doing that angle and then just subtracting.
Yeah, but see how that's more work?
Yeah, but like.
But if yeah, definitely. But you really have to understand what's happening. And yeah, there would be no problem with that. And you know what? You probably end up getting something like that in one of the rigor questions. But not when we're trying to just get some numbers right away, easily. Okay? Oh yeah, here. Go ahead, try it out. What'd you end up with?
Wait a second, what? 3.6. I don't like it. Trying to figure out what to do. Yeah, but in order to convert it to degrees, you have to have it high.
This is a good question here, right?
It doesn't.
No, not a good question.
No, I mean it is, but you have to actually think about it. Okay, so we have to convert it to radians.
What'd you get?
Well, I know because then you have to have to be degrees.
Okay. Nice try though. Nice try.
Wait, what number are we doing?
48.
D.
48.
We're doing number D.
Yeah.
36.
Joke, it's letter D.
No.
Okay.
Wait, is it a big number? Is it a big number?
Hold on. Now for starters,
I had a different one. I erased it.
is this 3.6 degrees?
It's the same. No, it's the same.
That means I'm in radians, correct?
Yeah.
So,
So I was right.
so,
3.6.
this is pi, correct me if I'm wrong,
Yes.
right? What is its equivalent in the length? 3.14. Oh, that's 4. 3.14, correct?
Yeah.
Is this bigger than 3.14 or less than 3.14?
Or what?
I'm sorry, I honestly not.
So that means that this angle is over here somewhere, right?
Yeah. Oh,
So when I come back up and I want to find whatever that's supposed to be, I'm going to take 3.6 and subtract from that 3.14, which will give me
0.46.
0.46.
Radians.
0.46
Radians.
Radians.
So then you
No
would do.
degrees, man. I'm just playing.
What is
Radians.
That was cool.
What's
That-
in
that-
degree?
that is
Convert it.
I don't know how.
0.4. Yeah, what are you talking about? You better know how.
0.46 times
0.46 rads
180.
times 180 degrees over pi rads. So do 0.46 times 180 and then divide it by pi.
It's 82.8.
82.8 degrees.
Wow.
That was just funny the way you said it. Wow, I wasn't even close.
Me on I tried so hard. I was over here and I was like,
So, let me show you. My gosh. I've got 7 minutes to get through this.
Not a lot of time. There's not much left, is there?
But take a look. Here's an example. We want sine of 135, right?
Correct.
Where's 135? It's in here, correct?
Yeah.
So I'm going to come down here and I want theta. Yeah, so what's 180? Take away 35? Is it 45?
135.
Oh, so it's 45 degrees, right? And I know that it's 1, 1, radical 2. Therefore, the sine of 135 degrees is going to be 1 over radical 2. Trig. questions? Do you need to see more? No, I'm done. I'm tapped. 1, 2, 3.
Are we done?
We're done.
Are we gonna have homework today?
Wait, so what are you guys on tour? We take a video. Explain. Give my one question.
So if you know, so here's what I'm saying. If you know, like, all those coordinates that you do on the unit circle, because you know how they give to you, I could care less. I'd rather draw the circle and I'll get what you're looking for. But if you want to do that, so let's say I'm going to 30 degrees, okay? There's my first one. I know from this is that the more I draw it, the worse it gets. I know this. I know that sine, sorry.
Why is it sine of 30?
3. I know that x is cosine. So here the coordinate would be radical 3 over 2. And the sine is opposite over hypotenuse, which would be 1/2. See how I did that? And then I could also find the 60. I could also find the 60 the same way. Okay? Here's my 60. Cosine would be 1/2. And then my y value is sine, which would be opposite over hypotenuse, radical 3 over 2. And if I wanted to do the 45, well then I draw my 45. 1, 1, radical 2. And I can see that it's going to be 1 over radical 2, comma 1 over radical 2. And if I rationalize it, you go from there. These are what matter to me. This, I can produce that all day long.
Go ahead. And then the next one.
Right, so if I keep going, let's do what is that, 90 plus, let's do 35? Oh no, you said negatives, right? Well, yeah, it would end up being negative here because here I've got, this is a 135 degrees. Let's say it's 135, okay? It's still a 45 degree reference angle, but now I have to think about it, okay? It's still going to be radical 2 over 2 for both, but cosine needs to be negative, and sine needs to be positive. And that's how I get the sines. That's what this slide was about. Right, and that's what the point is. So, you understand where it's coming from? Cool. No way, you're bad for it. Because she would always ask me why. Why? And now no one tells